Okay, good afternoon class. So we're just going to look at the last part of the trigonometry. Okay, we know we're doing both in one lesson. So as we know, the holiday is starting soon, so I can't leave you without anything. Okay. So this is for exercise 8, which is on page 108. Okay. There are two examples here. So this is example 1. Example 1 on page 108. Okay. Example 1 on page 108. Okay, so now we're solving equations using compound angles and no calculator. Okay, compound angles and again with no calculator. Okay. So the question says solve for x if sine 3x minus 20 is equal to sine x plus 10 for x is greater than or equal to negative 360 but less than or equal to 360 degrees. Alright. So people, what do we notice here? What do we notice here? We have signs on either side of the equal sign. Not so, and there's no number other than 1 as the coefficient of the ratio. Can you see that? So in that case, we can say that we can drop the signs here. Not so signs of function. So we can drop the signs there, and then we'll get our reference. 3x minus 20 is equal to x plus 10. Okay. You must remember that if you got we don't do logs are in. Yes. Okay. So log a is equal to log b. If that is the case, we know that a is equal to b. There's some restrictions that of course applies. Not so. As you can see, logs of functions there as well. If you got sine of a equals sine of b, that's the same as saying a is equal to b, and of course there's the restrictions that the general solution that goes with it as well. You understand? So if you can drop logs on both sides, we're left with that. We can drop sines on both sides, or causes, or tans, with whatever the angles are would be then equal to each other, provided that you go with the general solution. People, does it make sense? Alright. So what we now say is, we've dropped that, gives me a reference angle. So which question comes to mind? The question I should be asking myself, in which quadrant is sine positive? And we sine positive quadrant 1 and 2. So how do I get into quadrant 1? I just say it's going to be 3x minus 20. We've done this in grade 11 as well. Exercise 7.13 and 7.12. Out of that exercise, the clever maths is this exercise is there. So it's going to be 3x minus 20 is equal to x plus 10 plus k times 360. Why k times 360? The period on the sine graph is 360. So we're just going to tighten this up a bit, bring that over, take that over. 3x minus x is going to give you 2x is equal to 10 plus 20 is 30 plus k times 360 divided by 2. So x is equal to 15 degrees plus k times 180. So let's go with another quadrant, quadrant 2. How do we get to quadrant 2? It's going to be 180 minus, so remember, put a bracket around here, 180 minus x plus 10 plus k times 360. Okay? So that gives me 360 minus 20 equals 180 minus x minus 10 plus k times 360. X is one side, so it's going to be 4x is equal to 180 minus 10 plus 20. So it's going to give you 190 degrees plus k times 360. Is that correct? Alright, divided by 4. So x is equal to 90 divided by 2 is it's going to be 95. 95 divided by 2. 142.5. 147.5. Check. What is 190 divided by 4? Sorry? 47.5. Plus k times 90 degrees. Where k is an element of integers. But now coming back to my interval. It's from negative 360 to 360. Negative 360 to 360. So what do I do now? I start listing. Okay. So I say x is an element of, normally we don't write this, no? But because it's on top there, we're not seeing it. So we start with the first branch. We start with 0. Not so, put 0 through there, I'll get 15 degrees. If I put 1 in, we actually k now, it's going to give you 195 degrees. Not so. So I can now check with 2. Although it says without the use of a calculator, this part doesn't warrant what they are talking about. Okay? Adding and subtracting, they're not referring to that. They're referring to working with the angles and those things with the calculator. Okay? So that is going to give you 15 plus 2 times 180. Remember, it must be within that 360. So it's over. So I don't even write that down. Let's try minus 2 and minus 1 I should have tried. So it's negative 3, 4, 5. Let's go with negative 3 is definitely less than negative 360. Okay, so let's go with negative 1. It's negative 165. Okay. Let's go, of course, I said negative 3, but it is not working. Now we go with the other branch now. We start with k to be 0. If k is 0, I get 47.5 degrees. If k is 1, so it's 47.5. 47.5 plus 180. Well, no, 90. There's just going to be a few solutions there. So it's going to give you 137.5. 137.5. It's okay to be 2 now. To 7.5. Let's try 3 now. I don't think 4 will work, okay? 4 will be outside. So the next one, minus, of course 4 will be out, okay? Then I go with minus 1 now. So minus 1 gives us negative 42. Negative 42.5. If I go with minus 2, negative 132.5. If we go minus 3, negative, sorry, 222.5. Next, negative 0.5, and of course minus 5 will give you outside. Okay, will you guys understand? In the new textbook, did I give you all of those solutions there? Huh? So that's a lot of solutions. Normally they don't give you so many, okay, to work on. Because if you could have worked out the first 3 in each branch, is over enough for you. Then we're sure you can work out the first 100 as well. Okay. But you guys understand? Any confusion, people? Just remove the calculator really quickly. You can just confirm the answers behind. Alright. The last one. Example 2, and also on page 108. Alright, so we are told find the general solution of cos 2x cos 30 minus sin 2x sin 30. People, what does this remind you of? Cos alpha, cos beta minus sin alpha, sin beta. What does it remind you of? Cos, say cos. Yes, the cos double compound angle is. Well done. Right, so it's going to be plus or minus between the angles. not minus is well done, plus. So it's going to be, remember the rule says cos of alpha plus beta is going to be cos of alpha, cos of beta minus sine of alpha, sine of beta. Remember? Right. So what is your alpha in this case? 2x. So what's your beta? 30. So it's 2x and 30. So what must be here in the bracket? 2x plus 30 equals sine of x. So what do I notice here? We've got cos of an angle equals sine of an angle. But what did we say of a different angle? What did we say? If there's a coefficient of 1 here in front of the cos, or a coefficient of 1 in front of your ratio, then I can make the ratios the same and then drop it. So how do I get this to be the same as the cos? Cos of 90 minus. So I say cos of 2x plus 30 equals cos of 90 minus x. Can you see that? So what do we do now? We can drop the cos's, not so. So we say reference 2x plus 30 equals 90 minus x. What's the question that should come to mind? Which quadrant, yes? Is cos positive. So which quadrant is cos positive? 1 and 3. Oh, cos. Sorry. 1 and 4. So how do we get into quadrant 1? It's going to be 2x plus 30 equals 90 minus x plus k times 360. Why? The period on the cos graph is 360 degrees. So now x is one side, numbers are the other side. So it's 3x is equal to 60 plus k times 360. Divided by 3. So I get 20 degrees plus k times 120, where k is an element of integers. Okay. So how do we get into quadrant 4? Quadrant 4. So it's 360 minus, so x is equal to 2x plus 30 equals 360 minus 90 minus x plus k times 360. Now the people that works with a negative angle, they would say 2x plus 30 equals negative, open brackets, 90 minus x plus k times 360. Okay? This is another way of writing the same thing. So you've got 2x plus 30 equals 360 minus 90 is 270 plus x plus k times 360. Okay, so now it's just a matter of solving for x. So it's going to be x is equal to 270 minus 30 is 240 plus k times 360. And as I said, that is enough if you write it once in the sum. Alright. Sorry? What are they doing in the textbook? They're doing about the same. But as I said, man, they work with a negative angle here. So remember that when we introduced, we said that's going to be quadrant, this was going to be a theta, and this 180 minus theta, not so. But what they do is they say this is negative theta. This angle is negative theta. Okay? And this angle here is going to be negative 180 plus theta. Okay? So they work with negative angles. Okay? But I just find it, the learner finds it easier to work with positive angles. But there is learners that find the negative angle easy. Okay, but because I've taught you working with positive angles, you don't understand how the negative angles work. But some textbooks, they only use the positive angles. Okay, and in the exam, we mark both. We know how to mark both anyway. understand? And if your answer in your textbook is negative, then the way you check it is like this one here would have been negative. You would have seen that one is the same, not so? Then what you do is you take 240 minus whatever value is here. Okay? So if you say on the calculator 240 minus 360 is going to give you negative 120, not so? So the solution that they have is x is equal to negative 120 plus k times 360. Okay? And that is full marks you're going to get for either or. Okay? Anything else that you guys confused about? So with that you should be able to do exercise 8, and exercise 8 is on page 108. Okay? That basically brings us to the end of this part of trigs. We've got one section left, which is your 3D problems. Okay? 3 dimensions. Trigonometry. Okay? I think we'll start off with that the first week of next time. Alright?